All right, third attempt at recording today. This is lesson 1.6, worksheet 19 through 20, functions and operations. We're going to be adding, subtracting, multiplying, and dividing functions and putting one inside the other and talking about domain restrictions. So, review of domain. Basically, the only things you have to worry about for domain, okay, any kind of polynomial where there's no x in the denominator, it's just all real numbers. As long as there's no square roots anywhere, the domain is all real numbers. If you have a function that has a fraction with an x in the denominator, a variable in the denominator, you have to set the bottom equal to 0 and exclude that x value. If you have a variable inside a radical, you have to set whatever's inside the radical greater than or equal to 0 and solve. We've practiced this several times this year, so we're just going to keep going with those concepts. So I'm going to go real fast. You don't need to write this down, but if this was our function at the end today, you would say, well, the denominator cannot equal 0, and then you could factor or you could square root this one, and you say x cannot equal 1 or negative 1. Does that seem okay, guys? I went fast, but this one is written weird. I don't think I want to deal with that. You know what? That doesn't factor, and so I don't think we would have a domain restriction. I'm going to skip that one. And this one you would just say x cannot equal 1. All right, so just reviewing those real fast. All right, so 1.6 says two functions can be added, subtracted, multiplied, or divided to form a new function. For the new function, the domain consists of the intersection of the domains of the two functions, excluding any values that would make the denominator 0. In other words, the domain is the values of x common to the domains of the two first functions. Don't get too worried about it. It just means if something wasn't in the domain of the first function, it's still not in the domain of the new one. So the operations, adding can be written like this or like this. It means the same thing. Okay, so often it's written like this in calc and pre-calc, but it means you're just adding them together. Is everybody okay? Subtracting, same thing. Multiplying can be written several ways. Sometimes it's just written as FG, but it means multiply F times G. And then dividing means dividing. Be very careful if they wrote it as F times G of X like this. It is not the same as F of G. We're going to talk about this open circle thing in a minute when we do composition of functions. Kind of like pumpkins. I don't know what I'm saying today. All right, this is one I would put on a test or quiz. It just says add them together. So you would take this and add this. The like terms would combine. They wrote it out here. They showed you would add them. These would combine, and they ended up with x squared minus 4. You don't factor, you just leave it. Okay, it's a plain old polynomial. So does it have any domain restrictions? Nope, we're done. Domain is all real numbers. All right, this says put f over g. So you would write f on top of g, that's it. This particular one though, you could factor the top, and does anybody see what happens here? This factor cancels. Do you remember? No one's gonna cancel anything here, right? Remember my killing kittens meme? Okay, you cannot cancel as long as there's adding and subtracting going on. But if you factored the top, right here, there's an x plus 2 and an x plus 2, you can cancel that entire quantity. So this reduces to x minus 3. F over g is just x minus 3. But the domain restriction that happened at the beginning still exists. So you would have to say where x cannot equal negative 2. I'm not going to put that on a quiz, but that is how it works, okay? If it wasn't in the domain earlier on, it's still not. All right, ready? Practice. Here we go. f minus g. I would highly suggest you write this in parentheses because the minus ones get students every time. You're taking this entire function f and subtracting this entire function g. What's somebody going to do that's not right? They're going to forget to distribute that negative, yes. So this becomes x squared minus 3 minus a 3x, and minus a negative 1 becomes plus 1. Then we just combine terms. X squared, there's a negative 3x, a negative 3 plus 1 is negative 2. This is our new function. Were there any domain restrictions anywhere? Any denominators or radicals? Nope, so this is all real numbers for the domain. F minus g, we're good. All right, f times g, that is a solid dot, so this is multiplying. So we'd have x squared minus 3 times 3x minus 1. All right, can you distribute? Double distribute? What's x squared times 3x, guys? Make sure you're understanding your exponent laws and rules and you're multiplying. X squared times minus or times 3x would be 3x cubed. Everybody okay? Then x squared times the negative 1 at the back would be a negative 1x squared, which you don't have to write the 1. Inside here, we'd have negative 9x. And then negative 3 times negative 1 would be plus 3. And I don't think anything could be combined there, right? No like terms? So we're done. Are there any domain restrictions? Nope, no radicals, no denominator. So domain's just all real numbers. All right. This is kind of an ugly one because one of these already has a domain restriction. X cannot equal 0 right here on G, because it has an X in the denominator. Now, these are not as complicated as they look because there's not a lot of combining we can do. So the first one, F plus G, you would just add the two functions together in whatever order you wanted. X squared minus 1 plus 2 over X. There aren't any like terms, and I don't really care what order you have them in. And then you would say X still cannot equal 0. For F minus G, anybody tell me what that one would look like? It's just as easy. X squared minus 1, and then what? Yep, it just says subtract G, so it'd be minus the G function, which was 2 over X. That's it. X still cannot equal 0. Then it says F times G. F times G would be X squared minus 1 times 2 over X. Ugh. If I distribute this, I'd get 2x squared over x minus 2 over x. What could this one become if you wanted it to? You could, yeah, just have 2x minus 2 over x, and still x cannot equal 0 because there's 1 in the denominator. I'm not going to ask you one like that, and honestly, if you had left it, you could have multiplied the x squared minus 1 into the numerator and just put it all over that, because this is all over 1. I really don't care. Not going to put one of those on a quiz. Oh, I forgot one. Forgot one. The last one is f over g. So I'm going to write that as a division the first time I write it, because it's x squared minus 1 is being divided by 2 over x. What do you do when you divide fractions? Multiply and flip. Which one do you flip? First one or second one? Second one. You multiply by the reciprocal. So you change it to multiply and you flip the second one. So now I have x squared minus 1 times x over 2. If I distribute across the top up there, because this is like over a 1, I'd get an x cubed minus x all over a 2. We can leave it like that. But what was the restriction from the beginning that we still need to carry with us? Yeah, x can't be 0 from the very beginning because it was never included in that first function for g. All right, number 2. Can I get any of you to help me out here? What would it look like if we just added those? It's not going to be anything exciting. It's just going to say what? Plus 4x minus 7 plus a square root of x. Okay, what is the domain restriction when you have a radical? We've done this on quizzes twice. What's underneath the radical has to be what? Greater than or equal to 0. So if you were writing interval notation, it would be 0 and up, but I'm fine with you just saying x has got to be greater than or equal to 0 at this point. I don't care. The next one would be minus. What's the only thing that would change on that whole line? Instead of plus square root of x, it's going to say minus. All right, multiply. Ooh, not so cool. X squared plus 4x minus 7 times the square root of x. There's nothing nice you could do here. If you distributed this, you would just have an x squared times the square root of x plus a 4x times the square root of x minus 7 square roots of x. Honestly, I would be fine if you just left it. I'm not going to ask you one like this. So either one of these is fine, but again, x has to be greater than or equal to 0. And the last one, f over g, you would put x squared plus 4x minus 7 all over the square root of x. Now, I'm not going to worry about the fact that you can't have a radical in the denominator for this. Let's just not worry about that. But it does change the domain restriction. Because usually we say it has to be greater than or equal to 0, but can we have a 0 in the denominator? So it's just going to say what? It's got to be greater than 0. It can't equal 0 because it's in the denominator. Again, not putting that on a quiz. All right. Composition of functions is when you put one inside the other, okay? The compositions of functions, the result of one function is used to evaluate a second function, and you read it inside out. I don't know if you've seen it this way before, but this means put g into x, okay? G into f, I'm sorry. This means put g into f. When we're going to use this new notation, it's going to look like this. This means backwards, you're putting g into f. Okay, put g into f. If it's this way, then you're going what? F into g. Okay. Another method to combine functions is called a composition. F of g, the composition f of g is defined as, I don't really know what they wanted us to write here. I'm going to say put g into f, just so that you're clear that it was going put g into f. The domain is basically the same as what we've been doing. What if it wasn't in the domain originally, it can't suddenly be in the domain now. So let's figure out what that even means. So f of g, it says here's f and here's g. If you were asked to do f of g of x, I used a square bracket, okay. If you were asked to do this, you're putting g into f. So you're putting g into here wherever there used to be an x. Okay, this one's already done for you, so you can just watch, but it would be 3 times 4x plus 2 squared plus 2 times 4x plus 2 minus 1. You're putting this 4x plus 2 in for each of those x's. Now, this is a nasty problem because somebody's going to say this is like 4x squared plus 4 or 16x squared plus 4. But do you remember we've talked about this several times? If you square that, you're going to get 3 terms, yes? You have to FOIL out 4x plus 2 times 4x plus 2. I'm not going to take time to do it. They did it. 4x plus 2 times 4x plus 2 gave them 16x squared plus 16x plus 4. So 4x plus 2 times 4x plus 2 wound up with a 16x squared plus 16x's plus a 4. And then they still had all this at the back. They distributed the 2 back here and said plus 8x plus 4. And there was a minus 1. Then they distributed the 3. Then they combined like terms. There's a 48x squared. 48 and 8 would be 56x's. And a 12 plus 4 is 16 minus 1 is 15. Did I get it right? Okay. That's how they got that mess. Now, much easier. This one says put f into g. Anybody know what that's going to look like? You're putting all of this into g. So you're writing down g. There's g. But what am I going to put in there? Yeah, the whole f thing. 3x squared plus 2x minus 1. Do you see why this one's easier? All you have to do is distribute that 4 and add the 2, add the like term at the back. I got 12x squared plus 8x minus 2. Did anybody else get that when they did g of f? Okay. Any domain restrictions on these? No, because they're just polynomials. There's no denominators and no radicals. All right, let's try one of these. This says, okay, this is the important thing at the end here. It says find f of g of 4. And I'm going to show you 2 different ways to do that in a second. And it's just important because students do that wrong all the time. But here, this one said find f of g. How do you find f of g? What goes into what? G goes into f. So all of this is going in here. So it's 2 something plus 1. And what's going in is an x squared minus 2x minus 4. Can you simplify that? Let's see, 2x squared minus 4x minus 8 with a plus 1 would become a minus 4x minus 7. And the domain is just all real numbers. I guess it didn't even say we had to do that. Okay, g of f, we got to put f in here. Now, this is about as hard as I would probably ask you on a quiz, but I would ask one like this. Put f into g. So you're writing out g, But into those, you have to put f, which was a 2x plus 1. Is everybody okay? Did I lose anybody yet? Okay, this is where it gets nasty, though. Remember, you got to do 2x plus 1 times 2x plus 1 and distribute that. Or FOIL it together. Here you're distributing. Just lots of room to make little mistakes, right? 2x times 2x is 4x squared. 2x times 1. 1 times 2x. 1 times 1. And then I have all the leftover stuff from up above. Anybody get an answer? I have 4x squared. Ooh, look. 2x plus 2x and a minus 4x. Did that go away? 1 minus 2 minus 4 would be negative 5, yes? So all that simplified down to that. All right. If I ask you on a quiz to find f of g of 4, my suggestion is you don't do all of this craziness and put a 4 in. Here is f of g. We already found it, so we could put a 4 in there. All right? But could we have messed up before then somewhere? Yeah. So my suggestion is you just put the 4 into the g. What happens when I find g of 4, guys? Here's the g function, so I'd have 4 squared minus 2 times 4 minus 4. Anybody do that on a calculator? I think it might be 4. 16 minus 8 would be 8, minus 4 is 4. Well, that was weird, but g of 4 is 4. And then what do we still have to do? Put that answer now into f. Okay, so now we need f of, we just found the answer here was 4. So f of 4 would be 2 times 4 plus 1 is 9. Did I do that right? So f of g of 4 came out 9. Do we have another one of these that asks us to do this? Okay, because I'm not happy that it came out. Putting a 4 got out of 4. It makes it confusing when you go back to look at your notes. Oh, but I want to skip this one altogether. Is there one more? Oh, yeah. We'll try this one. Ooh, this one has a square root. Okay, we'll try this. Otherwise, I'll just make one up, real easy one. So what are we doing first to find fog or f of g, guys? Which one's going into what? Which one should I write out? Yeah, g is going into f. So I have this and a minus 2. And in here, I'm going to write x plus 3. That's it. There's nothing I can do that. I could write 4 square roots of x plus 3 and a minus 2 without the parentheses, but there's nothing more I can do. This didn't ask for a domain restriction, but we haven't done one with a radical that had an equation under there. Remember, what's under the radical has to be greater than or equal to 0? So that would be the domain restriction for all of these. Well, not all of them necessarily. Okay. Then we're going to go back and do g of f. So this time we're putting f into g. So we have a big old radical with a plus 3 back here. And we're putting in a 4x minus 2. Can we combine something under there? We'd get a 4x plus 1, right? Did I do that right? Okay. Now, if we set what's underneath there greater than or equal to 0, we'd get 4x is greater than or equal to negative 1, x is greater than or equal to negative 1/4. Is Does this include numbers that it didn't include before? This said everything greater than -3. But now it says it has to be greater than -1/4. Are we okay? Yeah, this doesn't include any extra numbers. It actually is a smaller domain than this. I'm not going to ask you that. All right. Last thing here, we're supposed to put a 4 into what first? 4 into G, then that answer goes into F, okay? I'm just spelling this out in words for you here. Hi. Thank you. Yep.
Can I just take it for 2 seconds?
Yes, absolutely. All right, guys, we're gonna put 4 into G first, so we would get a lovely what? Yeah, square root of 4 plus 3, which is square root of 7. And then we're supposed to put that into F. So F of square root of 7 would become 4 square roots of 7 minus 2. The good news is nothing simplifies, so you can tell what you did. So the answer is that F of G of 4 simplified to 4 square roots of 7 minus 2. Now, if we did this right, when we did it here, we should get the same answer. Is that the same thing we would have gotten if we'd put a 4 in here? 4 square roots of 7 minus 2? Okay, same thing. The only reason I don't suggest you do it that way, because on the quiz, if you made a mistake simplifying over here, you're automatically going to carry that through over here. So, all right. All right. Quickly. G into F would be this mess down in the denominator here. So you'd have 1 over an x squared minus 1 minus 1, which would become 1 over x squared minus 2. It doesn't say to worry about domain restrictions, so I'm not going to. You would have plus or minus square root of 2 or something, but I'm just going to go with no. Then it says g of f. Can anybody tell me what that would look like? Ooh. We're putting this in here, so we'd end up with a 1 over x minus 1 squared minus 1. Yep, I'm not going to ask that on a quiz, so I'm just going to leave it alone, okay? Just leave it all alone. Let's do this part, though. Can we do... Where are we putting the 4 first? 4 into G. So 4 squared minus 1. G of 4 is 4 squared minus 1, or 15. Did I calculate that correctly? And then you're putting the 15 into F. So F of 15 is 1 over 15 minus 1, or 1/14. Again, if we did it right, putting the 4 into our f of g function should give the same answer. 4 squared, 16 minus 2 is 4, 1 over 14. We got the same thing. All right, are we done? Oh, we got to do these reading ones. All right, you need to look at the one in front of you. You can't read mine very well. This is red, and it is labeled F. Then we have G and H. All right, help me out here. We start inside. We put 2 into what first? Put 2 into G. You're supposed to know how to read these. We did this earlier. G is this green one. If I put a 2 in there, what do I get out? Everybody see where 2 is down at -4 on the green? So this became a -4. Putting a 2 into G got me out a -4. Now I'm supposed to put that answer into F, which is the red one. A -4 into the red one gives out a, is it -9, guys? Okay, can you try this next one on your own? Put 5 into H first. What'd you get? -6. Okay, and then you're supposed to put that answer into G. So G of -6 would be over here at 4, I got. Yes, no? Okay. This is the same question, but written in different notation. It's different numbers, so you got to do it. But this means G of -3. So that's the green. -3 is what? 1? Everybody okay? Into the G function, if you put a -3, don't you get out a +1? Okay, and then H of 1. So if I put a 1 into H, I get out, does it look like 6? 1 into H, I get out 6. Okay, one more. Starting with F, which is the red one. If I put a -7 into F, what do I get out? 0. And then I'm supposed to put that into G, which is the green one. So what is G of 0? Remember, G of 0 means when X equals 0, what is Y? I got -2. Okay? So that's reading compositive functions. All right, everything is on Delta Math tonight, 1.6. Okay? I'm gonna stop.